Hello, Spreadsheet Nation. My name is Nate Larmond, and I'd like to do a catch-up video. If you were absent for um, the bike wheel trundle, let me predict my running time, let me actually test my prediction. Lab had a few parts. We had to figure out how to use a bike wheel as a measuring tool. Remember, measure the diameter, multiply by pi, that's the circumference. If the wheel goes around once, you have traveled one circumference. So in that way, you can measure a really huge distance in between, your starting line and your finish line. Let's see. Some people did 36.5 meters. Some people did around 10 meters. Shamar went 46 meters. So that's where the lab started. We didn't know how to measure this really big distance, but we figured it out. Any wheel is a great way to measure distance. Then we figured out our running speed, kind of to revisit how does height affect walking pace, our first spreadsheet exercise. Then we learned a new trick. We compared our predicted time to our actual time with percentage error. I actually lifted this off a student. Thank you so much for donating your intellectual property. Hang on, I gotta fix up the spelling. Predicted time, okay. Unit should be in seconds in parentheses. I'm just gonna fix up a few boo-boos here. Speed is in meters per second. So whenever you label a column heading, the variable comes first, that's speed, and then in parentheses, the unit label comes second. All right, so like I said, this is an old idea. We just did equals, clicked on the distance, divided by the time, and bang. That's how fast the subjects ran in meters per second. If you want to chop the number of significant figures, hit the little 0 with the arrow. Yeah, 2 or 3 is fine. So here's the new one. Let's throw this one in fresh. Percentage error, like I said, is a comparison between the predicted and the actual. And students actually realize that it starts with subtraction and then ends with division. So what you do is you find the difference first. So equals, open parentheses, predicted, subtract, actual, close parentheses, and then we divide by the actual. So it's not just the difference, it's the difference compared to the real time. Sometimes a difference of a second doesn't matter. If it's when the train is arriving at the station, who cares? But, if you're a baseball player and you're a second late after the baseball goes over home plate, that's no good. So that's why it's percentage error. The top is the error, and then the bottom, after you divide it, makes it into a percentage. You hit equals, that's 10%. So this was actually a pretty tight prediction. Let's see, Owen predicted he was going to run 1,440 inches in 6.3 seconds. And, excuse me, the prediction was 7 seconds. The actual time was 6.34 seconds. So pretty close. His prediction was only 10% above the actual value. Oh, of course, we grabbed the autofill handle, grab in the lower right corner, fill it down. Emily was 67%, her prediction. Michael was 102% above the actual time with his prediction. Jean was 155%. So these are really terrible predictions, but, who cares? We were just figuring out a new way to check our predictions. And Shamar was 53% below his prediction. So, the prediction was 53% below his actual time. He thought he was going to be a whole lot faster than what he actually was. Okay, so let's see, how does the distance the person moved affect the percentage error? So we highlight X, highlight Y, insert chart, and click on column, and we're going to change it to scatterplot. Let's label the chart and axis titles. This is percentage error between predicted and actual times for various distances. kind of wordy. Maybe there's a better way to describe our experiment. So this is the distance moved, oops, in meters, and then we wanted to see how the distance move affected the percentage error in predicted time. Actually, nothing in units for a percentage error. It's called a pure ratio. It would be seconds divided by seconds, which is 1. Anything divided by itself cancels out. Okay, so we got some labels on this graph. That's beautiful. Whoops, let me expand series. And let me put the trend line on here just to wrap it up. So, well, actually, let me fix the horizontal axis. Let's make that 0. There you go. And let's make the maximum 60, just to give a little bit of space on the right-hand side. So this is kind of interesting. Like for the short distances around 10 meters, we were like above 100% error. This is absolutely horrible. These are really bad percentage errors. And then as we went to bigger distances, the percentage error was shrinking. So that's kind of weird. Our predictions were more accurate for the bigger distances. And now the prediction was below the actual time. Everybody else's prediction was above the actual time, giving a positive percentage error. And this prediction was below the actual time, giving a negative percentage error. So there you go. If you missed the spreadsheet construction for can I predict my time to run whatever 40 meters, there it is. Thanks for watching. See you in the next